Dear students, welcome to lecture 3 of module 2, which is another problem in a magnetic circuit, parallel magnetic circuit. So this is the question. For the core shown in the figure, it is required to produce a flux of 2 milliweber in the limb CD. So this is limb CD, that is, this is flux phi 2 milliweber in limb CD. The entire core has a rectangular cross-sectional area 2 by 2 centimeter. Area of core is given. Magnetizing coil has 800 turns and the permeability of material is 1200. Calculate the amount of magnetizing current. As usual, we have done this similar problem in the last video. So read the question one more and draw the figure. Try to work out the problem parallelly with this video. So here this is the core, rectangular core. Size is 10 by 10 centimeter given and the area is 2 by 2 centimeter square. We know that these parameters we have to assume. Phi total flux, phi 1, phi 2 be the flux in other two limbs, and this is the total ampere turns we have applied, that is N into I. We have to apply phi to the portion where we are applying the current, or where is the coil. In that portion you have to apply the flux phi. Okay. Next we can see what are the given parameters. So what are the given parameters? First is flux, that is which flux phi 2 is given as 2 milliweber. Area is given. Number of turns is given, permeability is given. Since there is no air gap, only one permeability. So these are the given parameters. Area 4 cm square, number of turns 800, permeability 1200, and flux phi equal to phi 1 plus phi 2, where phi 2 is given 2 into 10 raised to minus 3. If you draw the equivalent electric circuit, this will be the form. That is mm of F equal to, what is the value? N into I. This is reluctance in the first path, flux in the first path, S1 reluctance in second BE portion, phi 1 be the flux in BE portion, S2 reluctance in third portion, and phi 2 be their corresponding flux. Now what about the length of these parameters? That is, here total length is 10 by here it is 20, here it is 10. So you have to find the length of each path for finding the reluctance, that we can see later. So from the total MMF, what is total MMF NI equal to, either you have to take this closed circuit or you have to take this closed circuit. Each closed circuit should include N into I. So if you write the NI equation, what is the KVL equation? N into I, this is N into I equal to phi into S plus phi 1 into S1. So either this part, MMF of BAFE plus MMF of BE, or you have to apply the second path, MMF of BAFE plus MMF of BCDE. So phi into S plus phi 2 into S2. So from these two equations we can see phi 1 S1 equal to phi 2 S2. Okay. So what is phi 1? Phi 2 into S2 by S1. So this is the equation required for finding the current. What is your question? Your aim is to find the current through the winding. That is, this magnetizing current is your aim. So N into I equal to, either you have to use this equation or you have to use N into I equal to second equation. Suppose if you are using the first equation, then let N into I equal to phi into S plus phi 1 into S1. Here phi 1 is unknown, so you need to find the value of phi 1. How will you find phi 1? Using this equation, phi 2 into S2 by S1. We know the value of phi 2. Unknown values are S2 and S1. And what is the equation for in general for finding S? S equal to L by mu 0 mu r into A. That is, length will vary depending upon the portion we have taken. and this the denominator portion is same. Mu 0 is 4 pi into 10 raised to minus 7, mu r 1200, and area is 4 into 10 raised to minus 4. Here one missing, 4 into 10 raised to minus 4. Okay, this is the equation for S. L by mu 0 mu r into area 4 into 10 raised to minus 4. Here what is this L? L depends upon the path we have taken. All the denominator parameters are same for all the values of S. We need to find which are the unknown parameters here. Phi is unknown, S is unknown, phi 1 is unknown, S1 is unknown. 4 parameters you need to find. We are having the data to find these parameters. So how will you find phi? Phi is obtained once you got phi 1 and phi 2. Phi 2 is known value. Phi 1 you are going to find out this equation. So phi become phi 1 plus phi 2. How will you find S? S equal to L by mu 0 mu r into A. What should be the value of L? Which is S area? S area is this BAFE. This is S1. Here is your S2. So what is the length you have to take for finding S? BAFE. So you need to get the value of BAFE, BE and BCDE. So you can see how you can get the value. Okay. See in this figure, this is the length BAFE. Here is your BE. This is BCDE. Can you say what is the length of BAFE? What is the value? Here is it 10 centimeter. But this distance is 2 centimeter, 2 by 2 centimeter. So 1 centimeter is skipping. So you need to get the distance from this portion, central area, central length. So it is 9 centimeter. 10 minus 1. Okay. Here also 9 centimeter. So 2 portion 9 plus 9. Then this distance total is 10. Here 2 omitted, 1 omitted, here also 1. Total is this distance 2. So 1, 1. So plus 8. So what is the total value? 26 centimeter. Okay, this is the length BAFE. The same will be the length for BCDE. Is it? So length BCDE is also the same value, 26 centimeter. Then what will be the length BE? BE equal to how much this distance? 10 minus 1 minus 1, 8. 8 centimeter. Okay. So these are the values of length. So we can take this to our PPT. So these are the values of length. Length BAFE is 26, BCDE is 26 and BE is 8 centimeter. Okay. Okay, next we are going to find the value of reluctance S1 and S2. S1 is L by mu 0 mu r into A. Here mu 0 mu r and A are same. L value is changing. Here L for S1 is 8. 10 minus 1 minus 1, 8. Here for S2 is BCDE. It is 26. So find these values and find the value of phi 1. Phi 1 equal to phi 2 into S2 by S1. So since I am directly dividing this, denominator get cancelled. So 26 by 8. So the value of phi 1, check whether you are getting it as 6.5 milliweber. Okay. Next you are going to find the value of ampere turn required to for BE. Ampere turn required for BE is same as BCDE. This is BE. BE is same as BCDE. Okay. So which is Phi1S1, that is same as Phi2S2. What is Phi1? 6.5 into 10 raised to minus 3 milliweber. So the value of Phi1S1, you substitute these values, you will be getting 862 ampere turn. Okay. Next you need to get the value of BAFE, the second portion. So BE you got, next BAFE. Then total will be your NI. So BAFE equal to phi into S. What is phi? Phi1 plus phi2. Phi1 you got, phi2 also you know. So phi1 plus phi2 is 8.5 milliweber and the ampere turn required for BAF is phi into S. Phi is 8.5 milliweber. S value, S is L by mu 0 mu R into A. So you will be getting 3665.6 ampere turn. You work it out in your notebook. Phi 8.5 milliweber. S, this is L 26 into 10 raised to minus 2 by mu 0 mu R into A. So total ampere turn equal to, what is the total ampere turn? Total ampere NI. NI equal to sum of these two, 3665.6 plus 862, total will be getting 4527.6. So NI equal to this value, so that is I divided by N. So 5.65 ampere is the current flowing through your magnetizing winding. Thank you.